Imagine this. What if we could build a bank, a social network, or maybe even a whole new internet that wasn't controlled by any single company or government? Well, that's the incredible promise of the blockchain. In this explainer, we're going to dive deep into its evolution, all the way from a simple idea for digital cash to a technology that could literally change the world. Let's get right into it. Okay, so this is what started it all. You see, the internet was built for sharing information, not for transferring value. To send money online, you've always needed a trusted middleman, a bank, a PayPal, you name it. The mysterious creator of Bitcoin wanted to build a system where you just didn't need to trust anyone at all. Right, so before we can even get to the genius solution, we've got to wrap our heads around the problem itself. And it's actually pretty simple. Digital things can be copied perfectly. If I email you a photo, you have a copy, but I still have the original. What's to stop me from doing the exact same thing with a digital dollar? That's the core challenge. And you know, Satoshi Nakamoto, the creator of Bitcoin, put it perfectly in the original white paper. This quote gets right to the heart of it. Relying on a bank means they can reverse transactions. Now, that might sound like a good thing, but it's the very reason why we have high fees, delays, and a system filled with uncertainty for merchants. And this is where Bitcoin steps onto the scene. It's not just another type of currency, it's a completely new way of handling trust. It's a system designed from the ground up to let you send value directly from me to you, peer to peer, with absolutely no one in the middle.
So, what is a Bitcoin really? It's not a file you can just copy and paste. It's more like a continuous public record of ownership. Every time a Bitcoin changes hands, a new entry gets added to its history. This is done by digitally signing a unique fingerprint, that's the hash, of the last transaction. What you get is this unbroken, unchangeable chain of ownership.
And here's how that transfer actually happens. You take the history of the coin, you add the next owner's public address, and you lock it all together with your own unique digital signature. It's like each new owner adds their own unbreakable link to the chain. And because this whole chain is public, anyone can look at it and mathematically prove who owns what.
Okay, that all sounds great, but there's a huge glaring problem, right? Digital signatures prove who owns the coin, but they don't stop me from taking that same coin and trying to send it to two different people at the same time. This is the infamous double spending problem, and it's the one thing that stumped digital cash pioneers for decades.
The answer to that problem is a piece of absolute genius called proof of work. The best way to think about it is like a giant global competition. Computers all over the world are racing to solve a really hard math puzzle. The winner of that race gets the right to be the official record keeper for the next batch of transactions, the next block in the chain. And in doing so, they secure the entire network.
So this is how the whole thing runs without a boss. New transactions get shouted out to everyone. The computers, or nodes, bundle them into blocks and start competing. Whoever solves the puzzle first broadcasts their block. Everyone else checks their work, and if it's all good, they add it to their copy of the chain. The key is they always build on the longest chain, which represents the one true history of transactions.
Now, for years, that's what blockchain was all about, a super secure ledger for digital cash. But then, a few years later, a new question started to bubble up. What if this technology could do more? What if the blockchain wasn't just a ledger? What if it could be a computer?
And this is probably the best way to think about the difference. Bitcoin is like a pocket calculator. It's designed to do one thing, handle electronic cash, and it does it incredibly well. Ethereum, on the other hand, is like a smartphone. It's a general-purpose computer that you can build any kind of application on top of.
Okay, transaction-based state machine sounds super technical, I know. But the core idea is pretty simple. Both networks are like a shared database that everyone agrees on. But where Bitcoin's database only tracks who owns which Bitcoins, Ethereum's can track, well, anything a computer can. Account balances, complex financial contracts, ownership of digital art, even entire programs. It's a single shared computer for the entire world.
All right, but if you have a world computer that anyone can run code on, how do you stop someone from writing a program that just runs in an infinite loop and grinds the whole system to a halt? That's where gas comes in. It's literally the fuel for the Ethereum network. Every single computational step requires a tiny fee paid in gas, which prevents spam and keeps the whole thing running. This whole concept of running programs on a blockchain has a name: smart contracts.
And what's really wild is that this idea is actually way older than Bitcoin or Ethereum. It's the philosophical bedrock that this all sits on.
Yeah, you have to go all the way back to 1997. A computer scientist and cryptographer named Nick Szabo was already wrestling with this. He understood that contracts are the foundation of our entire economy, and he was asking, how do we create reliable agreements in this new online world we're building?
And his answer was the smart contract. Honestly, the best analogy is a simple vending machine. You put your money in, you press the button for your choice, and the machine is bound by its programming to give you your snack. There's no negotiation, no need to trust the machine's owner. The rules are baked right into the code.
So, for these digital contracts to really work, Szabo said they needed a few key things. First up, observability. That just means everyone involved can see what's happening and prove what they've done. With a public blockchain, where everything is recorded on an open ledger, that's a big check mark. Next up, verifiability. You have to be able to prove without a shadow of a doubt whether the contract was fulfilled or broken. Well, on a blockchain, the code itself is the ultimate referee. It doesn't have opinions, it doesn't have biases, it just executes the rules exactly as they were written.
And finally, privity. This is basically a need-to-know principle. The details of the contract and control over it should only be shared with the people who absolutely need to be involved. It's all about protecting the privacy of the agreement. It's nobody else's business.
So let's just zoom out for a second and look at the journey we've been on. We started with a very specific problem, how to trust people online with money. And we've ended up with a powerful general-purpose platform for creating a whole new kind of digital world.
This timeline really puts it all into perspective, doesn't it? The core philosophy of smart contracts was floating around way back in '97. Then, in 2008, Bitcoin came along and actually solved the double spending problem. And then, in 2013, Ethereum took that solution and said, let's run with this. Let's make it a platform for everything.
And this really gets us back to Nick Szabo's original vision. He imagined using this technology to cut through all the messy, complicated stuff, like different national laws and jurisdictions, to create a truly global and seamless foundation for new digital markets.
And that's really the thought I want to leave you with. What happens to our world when our most important agreements are no longer based on a handshake or a piece of paper, but on lines of code that can't be stopped, can't be censored, and can't be changed? The implications for business, for law, and for the very idea of trust are just massive.